Hello all. Today we will learn about MOSFET. MOSFET means metal oxide semiconductor field effect transistor, one another type of FET. In the previous two videos I have told about JFET, that means the junction field effect transistor. So today we will learn about MOSFET, right? So today we will discuss only about one type of MOSFET because MOSFET have two types. One type is enhancement type MOSFET and the second type is depletion type MOSFET. And these two type of MOSFET has also two types. Right. The enhancement type MOSFET has two channel, like N-channel enhancement type MOSFET and P-channel enhancement type MOSFET. Same case for depletion type MOSFET. There has also two channels, P channels and N channels. So today we will discuss enhancement type MOSFET for only N channel, right? So first of all, look at the structure of N-channel enhancement type MOSFET. What we can see that here is one P-type substrate. We can tell this P-type body also. And there is two walls, two N-channel walls, two N-type walls you can see here. There is one N-type walls and there is other N-type walls, right? Now, we can see here three terminals, but in the basic case there is four terminals because in this terminal there will be one more terminal, that is substrate terminal or body terminal. Because of the source terminal and this body terminal is internally connected, so that we cannot need this type of terminal. We only need these three terminals because the source and this substrate are internally connected. Okay. Now carefully see the construction, the structure mainly. So here you can see it's silicon dioxide dielectric layer. You can see here, right? There is a silicon dioxide dielectric layer. I will discuss later about the working formula and the working function of SiO2 in this type of eMOSFET. Now only see the structure. Here is the source terminal, here is the drain terminal, and this is the gate terminal which is situated upper the SiO2. Okay, this is the metallization layer. That means this is the metallic contact. In three cases, in this of source cases, drain and gate, there is a metallic contact to touch in with terminal. Okay, now in enhancement type MOSFET, why we use SiO2, right? So we can discuss here the operation of N-channel eMOSFET, right? Okay. So look here. First of all, in previously I have told about JFET, and there we have seen the current is passing through drain to source, right? And the current is called ID current, right? But here you can see in the structure, you can see how the ID current will pass, because there is no channel, right? There is only two N walls. That is not channel. Reminder, there is no channel is created till now in case of enhancement type MOSFET. There is only two N channel walls. So N type walls. So how the ID current will flow from drain to source? Okay, the answer is here. You can see that we have to create one N channel here, okay, by the use of SiO2, by the guide of SiO2, that means silicon dioxide. How we can prepare? Okay, let's start. First of all, we have to connect the source and gate with a potential, that is called also VGS, right? And we have told previously that these p-type substrate, that is the substrate terminal and the source terminal, is internally connected, and the extra point is this internally connected terminal is connected through ground. So the S or the source terminal is 0 because it is grounded, right? So that is lower potential and this is higher potential when potential is added. Now, after VGS is added, we can see here that there is one metallic contact and under this one SiO2. Okay. Now, when the value of VGS is very low, right? Value of VGS is very low. What is the working function in this, right? So let's discuss. First of all, in p-type substrate, which is majority charge carrier, holes, right? In p-type substrate, majority charge carriers is holes and minority charge carriers is electrons, right? So now, this SiO2, the silicon dioxide, is working here as an insulator and also as a dielectric layer. Okay. Now, because for an insulator, when some value of potential is added here, that means when VGS is low, very low, then what happens? The minority charge carriers, that means the electrons, they will come nearer. You can see that they will come some kind of, when VGS is low, not this more than. When some kind of VGS, when some value of VGS is added here, then the minority only some electrons will come near to this SiO2. Okay, the holes is also here. So what can we see? In that case, the p-type behavior we can see here less than here, because there the minority charges is here very morely, like the concentration of that minority charges will very higher in this area than this area, because all the minority charges what as here that will come into this area, but the holes also in here. So what can we see? That the p behavior is less here. Okay. Now, when we increase this VGS, right? When we increase this VGS, what happens? The holes will be pushed down to here. How? Because when the VGS is increased, then the atom situated this p-type, the valence electrons will go out from the shell and there will be created one hole, and the electron which will be go out from the shell, that will come to this position. That means the charges or the value of charges of electrons will higher in this region more and more, and the holes will be down to earth, right? That means all of the atoms, that when VGS will increase more and more, the valence electrons will go out more and more, and the holes will be created, and the electrons will come near this region, and the holes will be created down to down, so the holes will be pushed down. This is the main reason, right? Now, how can this happen? This is happen because the silicon dioxide is working here as a dielectric layer. Then what is the function of a dielectric? Now, if we can consider the SiO2 as a parallel plate capacitor, you can see here as a parallel plate capacitor, if we can enter a dielectric, what happens? the capacitance of the capacitor will increase. So what happens? It will accumulate more and more charges inside the capacitor. Same cases here. Because of the dielectric behavior, the more and more charges accumulated here, you can see that. Then what will happen? You can see there is created one N channel because there is not now when VGS is already increased. Now there is no P-type behavior in this region. There is only N-type behavior. So there will be one N channel between two N walls. There will be created one N channel. Now the structure is ready to flow the ID current from drain to source. But before that, remind we have to connect the source and the drain with a potential or with a battery to give them voltage, right? Now, this voltage, we can tell this voltage as VDS, right? Because this is connected with source and drain. Now, when you increase the value of VDS, what will happen? The current will also increase. But can you remind the previous videos? In case of JFET, I have told that there is a counter effect of the VDS in case of JFET, that when the VDS is increased, the current will also increase. But there will also a counter effect of VDS. What is that? That the N channel will be very narrower in case of JFET. The N channel will be narrower. So what will happen? It will resist the current. It will resist the current to flow from drain to source. Same thing is happening here. What is that? That when we increase the VDS, the current will also increase and the current will flow from drain to source by this N channel. But reminder that I have not told in this video that when the structure is I have discussed about the structure, there will always a depletion region will happen because of there is a reverse bias will happen when we have connected the source in the so grounded voltage and drain is the upper voltage, so there will be a depletion region will happen previously. Okay, so when the ID, that means the VDS will add it, the reverse bias will happening more in this region. Why? Because when we increase the value of VDS, there will be in this region the N wall will be with higher potential and the P-type will in lower potential, right? So here will be more reverse biasing, so here the depletion region will increase. So what will happen with the increasing of this depletion region? The current will resist. The current will get resist and the current will resist to flow from drain to source. Now there have also one more point, that what is the pinch off region. Same case for JFET, I have told that there will be one time come when the current will saturate for a voltage, when the current will saturate and the value of current will not more. How? In this case, when the value of VDS is higher and higher, the depletion region will more and more in this region. So one time will come when the current will not increase anymore with the increasing of voltage, and that voltage is called here saturation voltage, right? Okay. Now, in this case, now what can happen if we want to flow the current after the saturation voltage? No, that we want that no, the current should be flow from drain to source. Then what can we told, that what can we see? Now For that case, we have to use this VGS, right? We have to increase this VGS. With increasing the VGS, what will happen? The channel will increase. The depth of channel will increase. So what will happen? The pinching region, the pinch off region will be less. So again the current will flow, and with the current flowing, again the depletion region happen, and again the current will saturate it. So we have to use alternatively VGS and VDS to flow the current, right? But one time will come that when the current will saturate, but that the time will differ. Time will differ that when the current will saturate. With the help of VGS, we can use the ID current more and more time to flow from drain to source, right? So here we can see this type of operation in case of N-channel eMOSFET, right? Okay. So now, I have told important two types, that is importance of SiO2 that I have told before. That what is the importance of SiO2? That as an insulator, because as an insulator, what SiO2 did? SiO2 do that the minority charge carrier will not go out from this region because of the insulator. So there will be the minority charge carrier will store here because of the behavior of insulator, right? Okay. Now, the pinch off moment or the saturation voltage. What is the saturation voltage? I have told in which voltage the current will saturate, in which voltage of VDS the current will saturate, that voltage we will call saturation voltage. There is also one voltage that we call threshold voltage, right? Threshold voltage is happening in case of VGS. With the increasing of VGS, one time will come that there will be a voltage, we call that voltage as threshold voltage. Okay. Now, the drain characteristics of MOSFET, right? What is the drain characteristics of MOSFET? Look here, the same thing for JFET we have seen early. Most probably the same thing for this MOSFET. The drain characteristics of MOSFET, we can see this is for the ID, this is for the VGS. Now, when VGS is low, what we can see, the pinch off region is come more and more earlier when VGS is low. When we increase the value of VGS, the current will pass more and more and the saturation time will come later and later, right? You can see here. So this is the main drain characteristics of MOSFET, right? Because this is totally dependent upon VGS, right? Okay. I hope you can understand the drain characteristics, because in case of JFET we have also seen this type of characteristics, right? Okay, now the symbolic difference between P channel and N channel MOSFET. What is the symbolic difference between P channel and N channel MOSFET? You can see here that is the gate terminal, that is the source terminal, and that is the drain terminal. Okay, in case of N channel, the arrow is inwards to the gate, and in case of P channel, the arrow is outwards to the gate. And remind this thing, the MOSFET body usually connected to source terminal, what I have told previously, right? So this is the main difference between the symbol of P channel and N channel enhancement type MOSFET, right? So you can see also here the symbolic expression and the explanation that how the arrow is inward, you can see in this picture, right? So today's lecture was about this enhancement type MOSFET for N channel only, and you have to remind about three things, that is, one, importance of silicon dioxide, second is pinch off moment, that means saturation voltage, and the third is threshold voltage. Okay, I will explain threshold voltage. I will explain the threshold voltage in the description below, because in there the connection of threshold voltage, I hope you may not be understand. So I will write in the description that what is the threshold voltage, and then if you have any query about that, what is the importance of threshold voltage in this MOSFET, so that I will discuss in the next video. And in that video I will discuss about depletion type MOSFET, right? And after that video you can realize the main difference between depletion type and enhancement type MOSFET, right? So I will end today's lecture. I hope all of you can understand this video, because I have only told about N channel. You can also understand for P channel, because the same thing will happen but vice versa, right? Because of P channel, for P channel there will be N channel substrate and there will be two P wells, but there will be the working function something different. But in this video I will only discuss about N channel enhancement type MOSFETs. Okay, so I hope all of you understood this lecture. If any type of problem occurs, please write in the comment section below, and any type of query, you can mail me. I will write the mail in my description. So for today I am ending the lecture. Stay safe all. Okay, bye.